So where we stopped off yesterday was with scalar multiplication. When we're multiplying a matrix by a scalar. Now the scalar, whatever the number is either going to make it bigger or smaller. Because if the number is a whole number, it's going to make all the numbers increase by that factor. Now if it's a fraction, something between 0 and 1, it's going to make it smaller. But on a whole, whatever the scalar is, we're going to multiply every element in the matrix by that number and either increase it or decrease it. So let's look at this first example here. We want to perform the indicated operation. So we want to scale this matrix by a factor of 2. So we're wanting to make all the numbers bigger by a scale of 2. So what that means for us is that we're going to multiply everything in the matrix by 2. So we'll do this, so we'll have 2 times 3. And we'll also have 2 times -2. And then the next one, we're going to have 2 times 1. And then we'll have 2 times 5. The next one we'll have 2 times 2. And then the last one we'll have 2 times 0. We're multiplying everything by this scalar of 2. Is all we're doing for these scalars here. Well, looking at this here, well, what is 2 times 3? And 2 times -2 is -4. 2 times 1 would be 2 times 5 is 10. 2 times 2 is 4, and 2 times 0 is 0. That's it. That's all we have to do on these here. Any question on this here? Now we can also use those scalars with addition and subtraction, so we can combine the two. So we'd want to use the scalar multiplied by the scalar first before we do any addition or subtraction. So here we're going to multiply through by -3. So we'll have -3 times 5 and -3 times 0. Then we'd have -3 times -2 and -3 plus, or times 4, plus our other matrix. Any questions on this here so far? Feel good with this here? All right. We can go on and multiply by the -3. Well, -3 times 5 is -15. -3 times 0 is 0. -3 times -2 would be 6. And -3 times 4 is -12. And that leads us to really to the next step, is adding these two together. So if we're going to add them together, we add the like elements. So our -15 plus 1, 0 plus 7, 6 plus 3, and -12 plus 2. So -15 plus 1 would be -14. 0 plus 7 is 7. 6 plus 3 is 9. And -12 plus 2 is going to be -10. Yes, so it would be -16. Let's get a small eraser, because this shouldn't be a positive one. It should be a -1. Yep, so that would give us -16, 7, 9, -10. Yep, thank you. Yep, drop the one negative sign and it changed the problem. Nice catch. Any other questions on these here? How do y'all feel about these? We like these here? We need to see another example of one of these. Now I feel pretty comfortable with it. So doing something like, let's say, -9 sevenths, 871, 462, 12, -689, -972, 51. And then let's say -1284, 68, and 1. Minus what, 19/27? No. Yeah, that's fine. 671, -246, 87, 921, -104, 57, -208, 51. What? That's a little too easy. Let's say 181. Wow, that's not too bad, is it? 871, 462, 12. -689, -972, 51. What is that? 12. Yeah, 1284. 68 and 1 minus 19/27. 671, -246, 87. And exactly, this really isn't any different. It's just we do have some fractional multiplication that we're going to do. 457. I think that's -208. 51 and the lovely 9/1801. So let's try it. So if I wanted to put these in the calculator, well, first I'd have to put the matrices in, yes? So we can go over to Edit. Now they are a 3 by 3, both of them. So we can say 871. Enter. 462. 12. -689. -972. 51. 1284. 68. 1. Well, that would be the first one. Then we go second quit, second matrix, over to edit, but this time I would go down to matrix B because we have 2 different matrices, yes? So we can put the next one in. Nope. 3. That would be, it is possible. So let's leave it a 3 by 3. 671, -246, 87, 921, -104, 57, -208, 51, and then -9 divided by 1801. That'll mess everything up. There we go. Now for this one over here, we could go alpha y equals enter and have this here and go -9/1801. Hit enter, and it'll give it to us. Now, most likely on the graphing calculators y'all have, there's a chance that it'll switch it over to a decimal, and that's perfectly fine. It'll be the same number. Okay, second quit. Now, the first part of this problem we had was -9/7 as a scalar, yes? let's type in negative 9 alpha y equals enter 7. Alpha y equals will give us the fraction. And then I want this is matrix A, yes? Well, second matrix, enter gave us matrix A, yes? So what the calculator is reading so far is that we want to multiply matrix A by the scalar negative 9/7. And we're subtracting from it what? 19 alpha y equals enter over 27. Now you could call up the fraction first if you want to do alpha y equals enter and then type 19 over 27. That'll be the same thing. And then we want what? Second matrix B. So I can scale down 1 and say B. And then we can hit enter. And it's going to think and give us this here. Now I want to see if I can force it to turn all of it into a fraction. Nope. That fraction down at the bottom right-hand corner is just too big of a number, too big of a fraction for it to work. But this here would be the answer. So these calculators can do addition, subtraction, and scalars. They can actually do multiplication if we wanted to. Even though we haven't necessarily gone over multiplication, second matrix, I can put them right next to each other and it understands that I'm multiplying A times B. And hit enter. And that there would be the answer. Let's see your math. Nope, it still doesn't like that number. And I can click over to get the full number, so it can go left, right, if this matrix C is too big for the window. We can also talk about doing inverses. Second matrix A's inverse. And it'll give us this here. It probably won't give us the fractions. Nope. But it can give us the inverse, and we can do determinants and different things the calculator will do for us. Now, we'll get into those at a later date, but if y'all end up taking the ACT before then and it asks for it, the calculator can do it. Well, second matrix. Okay, if I can get in the right menu. Second matrix. So math, DET, the first one is determinant. Because if it asks on the ACT to find the determinant of the following matrix, type it in and have DET, second matrix, well, not that. Second matrix A, enter, there's the determinant. It'll give it to us. This next one I find a little silly. Second matrix over DIM, but we can do it. And then go second matrix A, and it gives us this. Does anybody know what it's telling us? The dimensions is a 3 by 3. I find this a little silly because, well, to put the matrices in, I had to put the dimensions in, so we had to know them to be able to put them in. But it'll tell us anyways. Now, with multiplication, we would have to actually have something there for the dimensions, because the dimensions for multiplication do change a little bit. Edit, let's say, whatever, 78 by 3. So there's going to be a whole bunch of zeros. Second, quit. Second matrix, edit. Here, just by how it works, we'll say 3, and then say 98. Enter. I'm going to leave the rest of them 0. Let's go back up. One more. No, 2. And tell it to multiply those two together. Okay, so it's throwing a hissy fit because it's saying it's too big. Second matrix, edit. I'll make it smaller, let's say 20. Enter. Same quit. Second matrix. And the more that you mess with these and the calculators and utilize it, you'll be able to do these pretty quickly. and we get this here. Now, if I do second matrix dimensions, well, one of them was a 20 by 3, and the other one is a 3 by 20. Does anybody have a guess of what the new dimensions are going to be? Yep. 20 by 20. And this ends up, and we'll get into this later, but it deals with the rows and columns and how we can actually multiply together. Now, we won't get into multiplication yet. We will cover it at a later date and exactly how it works and how dimensions work and all that other stuff, because I think I mentioned the other books that we might get to. They delve into that. The book that we have now does not. There's stuff that it doesn't cover that the other one did. So if we do have time, we'll break those books out and use them. If y'all remember from last year, all of a sudden the Algebra 2 kids had those thick green books, showed them up. That's what we'll be using. So that'll get into more of it, but we're done. That is it. So that's all for chapter 1 that we're going to be covering. Now, we won't get into the multiplication or dimensions or any of that stuff, but most of the rest of the stuff we will cover. Now, tomorrow is a makeup day. I should be able to get all the assignments y'all just turned in and everything else graded so that you'll know exactly what you are missing tomorrow. I will have a sheet printed out that will have all the missing assignments on it, and that will be tomorrow. Thursday is a review day. I will give you the review sheet and you have the entire hour to work on it. Friday, for the virtual day, I will have a thing posted up for your attendance and assignment, and what your assignment is going to be 4 of those problems that I will select randomly. From that review sheet, you need to have a picture of the worked out solution, so your work on it, submitted into there for each one of those 4 problems. Putting just the answer won't count. I won't give you credit for attendance if you just put the answer for all 4. Because of those of you who had me last year, what's on the back of every review sheet? All the answers. So that doesn't tell me you actually did any work. That just tells me you just took the answers from the back. So I'm going to want to see the work on those, okay? So as long as you get me a picture that's somewhat clear and showing just the work, that's fine. And it could be the fact that you did it on Thursday, or not, Thursday. You already did those 4? Awesome. Just snap a picture of those 4, upload it, and you're good. And then Monday, what are we doing Monday? Nothing. I mean, if you want to do stuff, you can, because Monday we have no school. It is Labor Day. So there is no school on Monday. But Tuesday, we will be going over the review sheet. So any ones that you were stumped on or want to see worked out, we will do that on Tuesday. And Wednesday will be your chapter test. So we'll be covering that.